Hi everyone, I'm Cheryl. In this problem, we have a metal plate, and the temperature of that metal plate can be described by the function 80 minus 3x squared minus y squared, where T is the temperature measured in degrees Celsius and x and y are measured in centimeters. What we're asked to do is to look at the point -1,5 and determine the direction in which the temperature is increasing the most. And then after we do that, we're going to find what that actual rate of change is. All right, so let's begin by getting the direction. We can find the direction of maximum increase by looking at the gradient. So we'll look at the gradient of T of xy, which is going to be the partial with respect to x of xy times vector I, plus the partial with respect to y of xy times my vector j. My partial with respect to x, again, I'm treating y as a constant, so that's going to be a minus 6x times my vector I. The partial with respect to y, I'll treat x as if it's a constant, and so I'll have a minus 2y, and that's times my vector j. Now I'm interested specifically in what's happening at the point -1,5, so my gradient will be at the point -1,5, and so I have minus 6 times minus 1 times vector I, minus 2 times 5 times my vector j, so I have 6i minus 10j. And that gives me my direction of maximum increase. All right, well, what is that rate of change? The rate of change is going to be the norm of that gradient vector. And in particular, I want the norm of the gradient vector at the point -1,5. So that's going to be the square root of 6 squared plus a minus 10 squared, which is going to be the square root of 36 plus 100, or the square root of 136. And you can calculate that. The square root of 136 is approximately equal to 11.66. Now this is an application problem, so let's put the units on it. Remember the temperature is measured in degrees, and my x and y values are measured in centimeters, so that's 11.66 degrees Celsius per centimeter. I hope that was helpful. Thanks.